our third talk of the day is from Paulino Calderon. Hopefully I did not pronounce your name wrong, from Cozumel, Mexico. And Paulino is a published author and international speaker.
Hello.
With over 12 years experience in network and application security. He's also a co-founder of Websec, and he loves open source software, and that's how we found him. And he has contributed to many projects. So let's hear from our security expert today, Paulino, on securing your open source project. Go ahead and take it away.
Thank you. So I'll just wait until I'm a presenter so I can share my screen.
Correct.
There we go. All right. I'm unmuted and you all see my screen, right? Am I unmuted? There we go. Screen and everything is showing. So there we go. Good morning, good afternoon, and good evening, depending on when you're watching this. Today's talk is Securing Your Open Source Project. I'm Paulino Calderon. You can find me as Calderon on Twitter. And Jasmine already did a great job introducing me, so I won't waste your time doing it again. And we also only have 30 minutes. So I'm just gonna say I'm a security researcher and an avid open source contributor amongst many different things that I do. But I recently came across Alluxio, and I found a critical vulnerability that I reported privately to the team. And this is the talk that spawned and everything. So today I'll be sharing some of the technical details behind this vulnerability and the story about how I came across Alluxio. Some of the tools that I use to spot the vulnerability. I use CodeQL, a new tool developed by GitHub, and some other different tools that are amazing and that you can start using to secure your own open source projects. I'll be sharing a couple of stories from a security researcher's perspective on what sometimes can be a painful process of doing vulnerability disclosure responsibly. And finally, I can share some tips on how you can grow a healthy relationship with your security community and have a successful vulnerability disclosure program in your organization or open source project. So what's the story about behind this vulnerability? This vulnerability was rated as high or critical. It got assigned the CVE identifier 23848. I think I reported this back in January or February, so it was the beginning of the year. And what happened was that back in December 2021, the whole InfoSec community and I guess most of us were winding down and getting ready to take a few days off, go on the holidays and enjoy life away from the computer. But a critical vulnerability got published. This vulnerability was very, very critical. It impacted a lot of projects, and it affected a project named Log4j. At this point, because of all the publicity and all the impact of the vulnerability, most of you probably have heard about Log4j. But if you haven't, I think this meme describes it perfectly. Log4j is an open source project maintained by a single developer that runs in a lot of different infrastructure. So even if you're not using Log4j, you might be using Log4j because one of your dependencies is using it, and that's what makes it hard to spot that if you're vulnerable or not. And the interesting thing is that this vulnerability was very trivial to exploit. So attackers were taking advantage of this all over the place, and the whole internet panicked, right? And a bunch of researchers were looking into it, including myself. So I was investigating this vulnerability, looking for software that was affected or that were using this component and that was affected by it. And I came across Alluxio. So I'm not, full disclosure, I wasn't an Alluxio user. I came across it because Alluxio was using Log4j, and when I was looking through the files or looking through the source code, I spotted a different vulnerability that it is this CVE 2384.8. And what's this vulnerability about? Well, basically, Alluxio supports sending logs to a remote log server, and because they weren't validating the data of this object that was being received, it allowed attackers to send a malicious serialized object that when the application deserialized it, you could turn this into a remote code execution vulnerability pretty much. In Java especially, these deserialization vulnerabilities have been around for a few years, and they've been exploited quite actively since then. And they're probably not going away very soon because it's very convenient as a programmer to use serialized objects and just pass them around in between your applications or whatever that you need to do in between your classes, right? But what happens when you add malicious code into it and don't validate it? Well, it'll get executed. And a remote code execution is very critical for a web application because it will run the code at the system level. So that means an attacker can compromise the server that is running that application, right? Just to be clear, this application does not, this vulnerability did not affect every single instance of Alluxio. It affected the log server module of Alluxio. So since I'm not a user, I'm not sure if this is deployed like with every configuration or what's the deal with this module. But the vulnerability that I spotted was basically in the branches from 1.6, 1.7, all the way up to 2.4. So at that moment, I think it was all of the branches, and they were affected by it because of a class named Alluxio log4j socket node. And even though the name stated log4j, this was not the log4j vulnerability. This was a vulnerability, as I said, caused by deserialization. And what happened is we were basically, or they were basically taking an input stream and passing it to a class or a function called read object. And this read object deserializes the object, and you can trick it or you can inject malicious code into it so you get that remote code execution. The affected code is the one that is shown in the screen, on screen at the moment. You can see that how a thread was running or was receiving this input stream, and it was just processing it directly without any validation. And so it goes from msocket get input stream. I'm not sure if you see my mouse pointer, but it goes straight from get input stream to read object. So there were no validation in place, so this was trivially exploitable. As part of disclosing a vulnerability, I always like to include a proof of concept so it shows that it can actually be abused. And because there were no validation in place, there's already this wasn't too hard to exploit. There are already several tools available for attackers that help them use different gadgets uh, in libraries that are used within the application. And you can use these tools. In this case, I use WISO serial to generate a malicious payload. So I only needed to send this payload to the affected service. I think the default port for the log server in Alluxio is 45600. So I only needed to send that object and we will get our connection back. So this will force the server to connect back to us and give us a system prompt where we can execute further commands. So from this point, we will have the same permissions that Alluxio was running on. We could execute commands as the same user. So I shared that. You can probably find the video somewhere else or in my GitHub. I think I posted it. And this vulnerability got fixed. See, it got fixed on the 2.7.3 release. And this is the official alert that went out or I guess the changelog. And you can see at the bottom that it just says address and the identifier of the vulnerability linked to a couple of commits. Well, when I was preparing this presentation, I kind of realized that I'm not sure if the other branches got fixed. And at the same time, since I'm not really a user, I'm not sure if those branches are deprecated or if they're obsolete. But in case they're not, this is something very interesting and important to consider. Are you running all their branches, or is there a reason for you to run all their branches? Because the fix wasn't applied to those branches. And so how did I find this vulnerability? Actually, I use CodeQL. CodeQL, as I mentioned, is from GitHub. Full disclosure, I don't work for GitHub, but I do feel like they're doing an amazing job at securing the open source space. This is a tool made for static code analysis, and it allows developers or researchers to model vulnerabilities and use queries that use very similar syntax as SQL. So you could basically run SQL like syntaxes to analyze code bases. And the good thing about this tool is that you also can use it as a developer to automate security checks against your own application. It's free, and you can use the website lgtm.com to run and test queries against any of your open source projects. The query that is showing on screen is a query that I wrote as kind of like as an example back then. Uh, I don't know if you have heard the term three-star programmer, but basically in C or C++, you can have a pointer to data, but you can also have a pointer to the pointer that points to the data. And when you go beyond that, then you're considered a three-star programmer. So you can see the syntax at the beginning that it defines the language, it has some conditions, and you also select what information you want to display back to the user. So very similar to a SQL query, and it's very powerful. So from this simple example that is detecting, I guess, redirection levels or pointer levels, you can do a lot more complex things. For example, this is a query that I was using. This is the query that made me found Alluxio. So I was using this query to detect projects that were using Log4j, and you can see at the beginning how you can model a class based on the package name, and then from there you can run additional filters to match specific functions. So this helps you define your sources and your sinks. In source code analysis, this will help you track to see if input reaches your vulnerable function. So you can do this automatically by some of the functions that are embedded within CodeQL, and it's very powerful and fantastic. And the actual query that detected the vulnerability, it's already built in CodeQL. This is the query. You can see that there are some libraries already. And one of the interesting features is that it does the flow analysis. As I mentioned, you can define the module, what are your sources and sinks, and if there are any other routines that might clean up or patch your vulnerable code in between, you can detect that as well and model the whole thing. So it's very straightforward, but it can be very complex for some problems too. So it allows you to do anything that you want. It's very powerful. I really like it. And as I said, I don't work for them, but I think kudos to them because they're not only doing a fantastic job on CodeQL, they also have some additional projects that are very useful for the whole space. One thing that I like to mention is that first, it's free for researchers, and it's free for all open source projects. So you have the ability of run built-in queries that are being developed by them and by the whole open source security community, and you can use them for free on your own projects. They're already there. So even if you're not, you don't have security background, you can take them and run them against your against your project to detect problems. And if you're a security researcher, they even have a rewards program. So if you write new queries, you can even get a reward from them. This CodeQL can also be configured to run automatically every time a developer pushes new code through GitHub Actions. So that's fantastic as well. And they're doing additional things. For example, they're posting videos to educate developers. They're also last month they were holding office hours for open source developers for free. So you could book time with the GitHub Security Lab team, so they can help you set up, I guess, the security in your project, all the automated actions and all the projects or all the modules that you have available. For example, I don't know if you have noticed this, but in GitHub, there's a function called Dependabot or a program, and it helps you monitor your project against vulnerable dependencies. If you ever had a project with a vulnerable dependency, you might have gotten an alert from Dependabot, and it's great because it automates the pull request, it suggests a fix for it, and it does this by itself. And they have a similar feature for secrets. So when developers leave API keys or passwords or anything like that, uh, it also actively monitors against that, and it will alert you so you can remove it, revoke it, and act accordingly. So I think we're definitely going to see more from them, and they're definitely impacting the open source community. I, I've I've had some cases where the automated alerts were sent and the developers didn't believe it was a vulnerability, but just because they wanted to get rid of that alert, they fixed it. And it turned out that it was a vulnerability, and the developers just kind of like just fixed it by chance because of that alert, but they weren't aware that it was a serious vulnerability. So I think even in that way, they are securing the open source space. And I don't know if you noticed this, but there's a new tab when you go to GitHub. And in this tab, you can also, as a project maintainer, you can request a CVE if a problem is detected in your project, and it will alert your users. They also have a service, or they will offer you some help to write advisories so you can inform your users about this problem. And I'll talk a little bit more about this, but it is a good thing to implement, and I'll go over the reasons in a little bit. Now I want to share with you a couple of stories about how things turns out for security researchers when you try to do the right thing and do the responsible thing and disclose vulnerabilities in private. This doesn't turn out great all the time, and you have to consider that as security researchers, or at least for open source, we we are contributors as well. So we're not getting paid. Writing a technical report to disclose the vulnerability takes your time. If you want to reproduce the vulnerability, putting together a proof of concept code also takes time. So you need to take this in consideration because it helps you keep a healthy relationship with your security community. You don't want everyone to hate your product or have a bad reputation of not responding to vulnerabilities. And to prove my point, I'm going to share a couple of stories that happened to me with one of the biggest companies out there. So it has happened to me even with Google and Microsoft. So back in 2013, when Android was fairly new, I spotted SQL injections in content providers that they were at system level. Funny that SQL injections are not exclusive for web. It turns out that they also exist in Android components. And they are, if you're not familiar with them, they are interfaces to export data to other applications. So it's very similar to a traditional SQL injection, but within a system level. So a lot of components were affected by this. I reported it, and keep in mind that was in 2013. They didn't have a security rewards program back then. So I genuinely reported this just so they can fix it. I wasn't really expecting a reward or anything like that. So I reported this. It got assigned a severity, someone to fix it, and the priority. But then I got radio silence for 2 years. when I retested this on a newer version of Android, 5.x, in 2015, 2 years later, I noticed the vulnerabilities were still there, so they didn't do anything about it. I reported back in the same ticket, and next thing I heard a year after that is that, well, thank you for your submission. We apologize for not responding quicker. And since this is no longer valid or reproducible in our latest builds, we're just going to close the ticket. So a patch was never issued for these problems, right? And what happened after that is that 2 years later, I noticed that the vulnerabilities were still there. As I said, this was just kind of like a hobby of mine, so I wasn't really. If I did bug bounty as I guess full-time thing, I probably put vulnerabilities on a calendar, push on the vendors, be more pressing towards a patch and things like that. But since I kind of genuinely do it, so they fixed it. I reported it, and then life goes on for me, and until I remember, I kind of go back to it and check. So what happened is that I noticed that, and I told them I reported this in 2013, then again in 2015, and to my surprise, 2018, the vulnerabilities are still there. They made me sign uh, an NDA in case I got a CVE assigned, but after this, I had to send also a proof of concept code, and I'm not breaking the NDA because this is what happened. I didn't get the CVE assigned for me. It happened a similar thing. It passed like a year, I think, and they just closed the ticket telling me that they weren't going to fix it. But notice that actually it got assigned a P2 priority and severity as well. And so after some time, they just marked it as one fix. So oddly enough, a year after that, IOActive, security company, published an advisory affecting the same component. So I'm guessing either they found it later and they reported and requested the CVE and they got it, or it was a different issue. Well, same issue on a different module. But the point is that this vulnerability existed for at least 6 years. So the users were exposed to this 6 years, and you can see that not because they kept it private, that meant like the users were secure. Other researchers found it, and when you have motivated attackers, it is very likely that they're going to find it as well. So just keep that in mind. And a similar thing happened to me with Microsoft. Back in 2017, I was researching how to or how do malicious macros for Office work in Mac OS. In Mac OS, applications are sandbox, so malicious macros are a lot less effective because even if a user executes a macro, then the macro is sandbox within that word process. That means they cannot access files of the system and they cannot run commands. So it's pretty useless to run a malicious macro on a Mac. So it's pretty secure, a lot more secure than in Microsoft systems or in Windows systems. And what it did is, when I was looking into this, I found a way to escape the sandbox. So by abusing a known function or a function that was available in macOS, I was able to escape the sandbox and list the system files and execute commands and all that. But I was abusing an existing function. So I was misusing a function that had other uses for malicious purposes. And I reported it to Microsoft privately, and they created a ticket, told me they were going to look into it. And I think 2 months later, I didn't get a response at the time, and I was scheduled to speak at a conference, and I wanted to share the details, or at least, uh, like I said, I was doing this in the responsible way. So I was going to wait until they fix the problem so I can talk about it, share the details, because I also wrote a tool to generate these macros. So I knew if they didn't fix it and I released the tool, then a lot of users were going to be affected by it. So I waited and I kindly asked them to send me additional information. Did you confirm it? I'm scheduled to speak at a conference. I haven't heard from you back, but I'm not planning on disclosing anything yet. So just uh, let me know. They responded that they completed their investigations, and since the Office macro presented a dialogue before running my process, then it wasn't a security issue. And it didn't meet the security servicing bug bar at that time, and they weren't going to fix it. So I didn't get credit. They didn't, or they told me they weren't going to fix it. And to be honest, the problem that they're presenting here, or like saying that the security dialog is warning the user, it's a different story, because I'm telling them that I already know this, but when the user accepts this risk, you have the sandbox protection that is protecting them, or is blocking the macro to do actually any malicious actions on the system. But with this problem, if they click on it, then the macro gets a lot more dangerous, because it will be the same as running in Windows. They do have access to files, commands, etc. So I don't know. I talked about this problem with a bunch of people, and they all agree that this was definitely a problem. But I kind of like forgot about it, released my tool, and move on with my life. A few months later, to my surprise, I think I reinstalled my computer. Uh, so I had to re-download Office and all that. And when I was doing that, I decided to test my payloads again. And to my surprise, the my techniques that I reported didn't work anymore. So I emailed them back like, hey, I downloaded the latest copy of Office today. All the issues that are related to this function that was called grant access to multiple files that I reported in March no longer work. But you told me that you weren't going to fix this. So I was told this didn't meet the security servicing bug bar, yet you fixed it. So do you have any more information about this? And when I got back, it's like, well, thank you for your email. There are multiple hardening and defense in depth changes that were released for Office in the last month or months. And it's possible that the attack vector that you reported is mitigated by one of them. Huh, right. So they fixed it silently, and I didn't get credit or anything like that. Uh, and that's the story. So you might think that by ignoring a security researcher, you're actually, it might work out for you. It worked out for Google or Microsoft. But the reality is that the users were exposed to this risk because in one of the cases I released the tool, and in the other case I'm pretty sure everyone knew about this vulnerability or the other vulnerabilities, or people at least were looking into these systems because they weren't really that hard to spot. So by ignoring the problem and not making it public, your users are exposed to the risk, and security teams are not able to assess the severity of a problem, right? So it's very important that you keep this in mind. And well, how did Alluxio do in terms of this? They actually did a good job. I got a response right away. They patched the vulnerability in the current branch. As I mentioned before, I noticed, it just come to my mind that they might have not fixed the other branches, but at the same time, I'm not sure if they are still active or if they're deprecated, obsolete, or whatever. They responded privately, and they scheduled a follow-up meeting where I got to meet Bin and Jasmine as well. They wanted to learn more about how I spotted the vulnerability, and I think that speaks a lot about this project because they are genuinely interested in the security of its users. And they even sent me a nice appreciation token, a shirt, a card that didn't have my name, by the way, but it had someone else's name. But I appreciate the gesture as you see, I wasn't expecting it, so it's a nice little thing. And of course, they invited me to talk to you today, so I get to share this experience. Hopefully you learn a little bit more about other tools that you can use in your own open source projects and how you're going to deal with security vulnerabilities in the future. So what happened here is that the changelog only included a line telling you that the vulnerability CVE 2022 23848 was fixed, but they didn't really tell you much about it. So if you go back to the original or to the official advisory, the one that was posted by the organization that assigned the CVE, it only states that okay, in Alluxio before 2.7.3, the log server does not validate the input stream. And this is not the same as the log4j vulnerability, but that's about it. Now, let me ask you something. Is this enough for you to assess if a vulnerability applies to you or not? Do all the users know if they have the log server? Is it embedded? Is it an additional module that I need to install? Is it accessible for everyone? Is it running on my systems? Um, and I think it's another thing that we need to consider is that if you're an Alluxio user, if you're running the application and managing it yourself, this might be information that you know. But in organizations, if it's a security team or the IT team, it's a different team that might not be your user. So with this description, it might not be enough for them to fully assess the problem. And this happens quite often because as security, you need to understand, does this apply to me? Is this very hard to exploit? Am I going to get hit by this? So if you publish the vulnerabilities yourself, you take control of this narrative and you're able to give your user as much information as possible so they can do the correct assessment and do it properly and do it right. So and this is what I wanted to like end my talk with, kind of like share you some tips from like sharing the stories and seeing what happens like in real life and other projects. I also work, I guess I mainly work in private consulting, so unfortunately, a lot of my research or a lot of the vulnerabilities that I find they are never public. It's just between my clients and myself. So when I do this for open source projects, I feel like there are some common mistakes done across all of them or most of them. And the first thing is that, okay, so you spotted a vulnerability, you want to let the team know, but you go to the website and you cannot find what's the process for handling the vulnerabilities. They don't have a clearly defined process for it. So it's sometimes you spend so much time at the beginning just finding the right person to talk to. And remember, you cannot just do a pull request or an issue on GitHub because then the issue will be public and you want to keep it privately. And that's why things like the security tab on your GitHub project that allows you to exchange information privately is very useful. Another advice is to keep the communication flowing. Let them know what's your plan, if you're planning to fix it, if there are changes, what's your expected timeline, because when you stop communicating, that's when people start doing what they want. And I showed a couple of cases or a couple of scenarios from my perspective, but uh, each one of us has a different mindset. I genuinely do it so they fix the vulnerabilities. So but what happened if it's a malicious attacker or someone who just wants to see the world burn, I suppose. A lot of researchers use the Google policy of just giving them 90 days. And if they don't fix it in 90 days, they'll do full disclosure, publish the vulnerability, the details, the sometimes even the exploit code. So, and this really pushes vendors into fixing them. But if you are upfront about it and tell them, okay, I need this amount of time to fix them, at least myself and a lot of security researchers will agree, and they'll give you more time to fix it. So be upfront about it. Let them know that you're working on it. But we understand that you have other things, maybe even more important than the vulnerability that we reported. But it's important that you keep them posted. And then uh, another thing that I think is very important to bring up is that the stigma around CVEs. The GitHub Security Lab actually posted a blog post, I think last week, about some of the common problems or the stigmas around the CVEs. And I think people often associate them to bad reputation, while in reality, we recommend that you issue CVEs even for vulnerabilities that are not critical, because publishing that information allows users and security IT to fully assess the problem and do it in a correct way. Because if you don't do that, then do you think all the security teams or all the IT teams are going to spend time researching, looking into something that is like, not well described, not available, not that easy to find? They're probably not going to. And they're not going to do a correct assessment of the problem. And they might not patch it when it was a critical issue or it could affect your infrastructure. So it is best to issue CVEs for all the vulnerabilities that you spot in your project, and just don't be afraid of them. It tells more. It says more about your project in a good way than in a bad way. And I do recommend you go check out that blog post because it does have some good points that you should all read. And then always, I think, although it's not necessary, uh, credits are nice. People, since they spend time on it, it's the same way when you acknowledge a contribution of a code commit. If they spend time, hunting the bug, um, writing the patch, sometimes reproducing the vulnerability, proof of concept code. It is nice just to, say thank you to them because it costs them time. And a lot of people might not do it, right? They might just know the vulnerability or find the vulnerability, exploit it for themselves, or sell it, or keep it like kind of privately for their own use. So it really encourage them, I guess, to be nice to your project. So this is what I'm talking about: keeping a healthy relationship with your security community. You want them to share the information with you and not weaponize it. So I think overall, this is all I had to share for today. You can find my websites, the company that I founded, and my contact on Twitter in case you want to reach out at me. And I will also be at Slack. So thank you for inviting me today, and I hope we all learn at least a little bit about the perspective of a security researcher working on open source projects. Thank you.
All right. Thank you, Paulino. I really appreciate it. I enjoyed your story quite a bit.